In this video, we will learn about unsigned and const data types. This video in part will be a continuation of the last video on data types and variables. So I will compare and explain how a regular data type that we covered in the last video, which is also known as signed, is different from unsigned. And now we will go ahead and create an empty file, and we can call it 06 data type.c. And here we will just include the header standard input output library. Now the things that we will be looking at are signed versus unsigned data type, usage and syntax of unsigned data type, and the third thing that we will be looking at is const data type. So what's a signed data type? So a signed data type is a data type that we covered in the last video, where a data type can have negative and positive values. And unsigned data type can only have positive values. So now what I will do is we will put together so we will have our main here, and now what I will do is I will have the regular char data type, and we can have average 1 equals 120 negative 128, and average 2 equals 127, average 3 equals 128. So this is the signed data type, and you can have signed right before char or not. It's fine either way. Anytime any of the data types don't have signed before them, what that means is that it's by default considered signed data type. So what we will do now is we will print the values of these. So right now we can see that we have negative 128 for negative 128, and for 127 that's fine, we have 127, but for 128 we have negative 128, and that's because the char data type, when it's signed, it has a range from negative 128 to 127. So anytime we have a value that goes over 127, what would happen is, like I mentioned before in the previous video, what will happen is called the overflow, and the number in a way becomes negative. So if we have now 129, what will happen is we will have negative 127. So if we run this, we will have negative 127. And then if we have 130, that would be negative 126, and so on, and it will come down all the way to -3, 2, 1, 0, and then again it will become positive. So this is what the signed data type looks like. Now what we will do is we will have unsigned data types, and what we will do is we will have unsigned char, and we can call it average one, and I will just put underscore u just so we can differentiate, just so we can keep the signed variables consistent with the unsigned variables. And again, we will do 127. And we will do 128. And actually here, I will keep the average 4 equals 129. I will keep the average 4. So now we will come down here and I will have printf, and we will have a new line. And now what we will do is we will print out the values for the unsigned variables. So now first what we will say is we will see the values for the signed data type variables, and then after that we will see unsigned values, and these are the ones that have u at the end. So we will compile this, and you can see that negative 128 is fine and 127. So these are all the ones that we looked at before. But now instead of having negative 128, we have positive 128, and 127 of course is fine. And when we have negative 128, we have 128 for that positive 128. And this number right here, 129, which was because of overflow, it became negative 127. But instead of negative 127, it still stays 129. So that's what happens when we have an unsigned data type, and the maximum value that we have, so that's for signed data type, that the range would be from negative 128 to positive 127. So now if you're wondering that what is the range for the unsigned data type, so it varies with the type of what kind of data type that you're working with. So we have unsigned char, and then we have unsigned int, unsigned short, unsigned long. So depending on the sort of unsigned that you're working with, the range would vary. But with unsigned char, we would have the range from 0 to 255. So if we do, so this here is fine. So now what we will do is we will have unsigned char, and I will call it max underscore u, and we will have 255. u1 and u2, and here I will do 256. Now what will happen when we have max u1 Actually, I will call it char max, and we can call it char max too. And here what we will do is we will have printf and we will do char max and char max too. So here we will get a message that unsigned conversion from int to unsigned char changes value from 256 to 0. So now that we have this, what will happen is that 256 will actually become 0 because the maximum value that we can have is 255 in a unsigned char. And if we do unsigned char max 3 equals 257, now what will happen is that 257 will become 1. And again, and these are the warnings where it says that unsigned conversion from int to unsigned char changes value from 256 to 0, like I mentioned, and changes value 257 to 1. And that's okay, these are warnings and we can just ignore these. And now we can run the program. And we can see that it prints the maximum value, which is this right here, 255. And for unsigned char 256, we have 0. And for unsigned char 257, we have 1. And again, what's happening is called the overflow. And hopefully I'll make a video in the future describing what exactly underflow and overflow are. And hopefully this will make much more sense that why these values get changed. But for now, just know that when we have an unsigned data type, what will happen is that we will, in a lot of cases, we will have the positive values, except in the case of an int. And when you have the int unsigned int data type, what you will see is that you will still see negative values. So I didn't want to use an int as an example to show what assigned and unsigned are and how they're different. And I thought that using char is a better example to show how char and how signed and unsigned are different from each other. Another thing that you can, so this is one thing. Another thing that you can do is you can also, so this was char, and if you want, you can do the same thing for short, and we can call it short and average equal 3276, let's just say 765, and we can call it short average 2 equals 32766 32767, and average 4 equals 32768. And short is also another data type, and there are a lot of these different data types, and I think the short has a range from negative 32768 to 32767, I think. And you don't have to memorize these. These are available all over the internet, and you can just do min or max of a certain data type. That if you want to know what's a min of short data type or max of short data type, you can just Google it or bang it, whatever search engine that you use, and it will show you the whatever min and max values of a data type are. And we will do average 1. And average 2. Average 3. And average 4. So now we will, so as you can see that we have 32765, that's fine, 66 is fine, 67 is fine, and 768. So positive 32768 becomes negative 32768. And now what we will do is we will do something similar, and actually here I will include average 0, and this will be negative 32768. Okay, so that's perfect. So we can see that we have negative 32768. Now what we will do is, just like how we did with short data type, we will have unsigned short. Average 0. And we will have U at the end. And we will do unsigned short. And we will have average 3, 32767, and average 4 will be 32768. And now we will print these. And we will have average 4, and now we will just print these. So we can see that instead of having negative 32768, we only have positive 32768. And again, this negative 32768, which here was really 32768, and we can see that we have 32768. And let's just say if we had short average 5 equals 32,769 and average 6 is equal to 32,770. So now if we use these 5 so what I and we will have average 5 and average 6. Now, one thing that I would say is that um, try and see if you can figure out what 5 and 6, what these values will become for the signed short data type, and what the unsigned short average 5 variable and average 6, what the values for those will be. So when we run this, what will happen is 768 will become negative 768, and instead of seeing 769, we will see negative 767 and then 766. And the unsigned short data type will stay the same, and we will just see all the positive values. And we will put a new line here. So like I said, we will have negative 768 for the fourth for average 4, and we will have negative 767 for 769 for positive 769, and 32,770 will become negative 32,766. And when we come down here, when we look at the unsigned, we can see that all of the values are positive. And now if you're wondering what the range for the unsigned short is, so what you can do is we can add 32,767 plus, and we can do 32,768, and this is the number that we get. So what that means is the range for unsigned short would be 0 to 65535. So that's a range that we can assign to unsigned short data type. And if we do unsigned short average 7 u equals, and we will just do 65535, and this will print the value, so that will be fine. And we will do 65536, and this will print a 0. and this will print a 1. And for these, for 65536 and 65537, what will happen is we will get error messages saying, actually warnings saying that the we're changing the int. So just like how it says unsigned conversion from int to short number. And like I said, 65536 will become 0 and 65537 will become 1. But it will still be fine. And when we run this, oh, I actually don't have the 9th. I don't have the 9th, so and again, you can ignore these. And you can see that we have 0 for the average 8, and then we have 1 for average 9, which is 65537. So this is pretty much how the signed and unsigned data types work. And now, and I would say that play around with these and see how like how different data types work. And another thing that we can do is, instead of using d, what we can do is we can also use u. And you will see that when we compile and run this, this will also work out perfectly the same way. And a lot of the cases when I've used u, a lot of the times when I've used percentage %u is pretty much when I'm using the int data type. And I would suggest that if you want to experiment with the int data type, what you will notice is that whenever you have unsigned int, and if you have a negative value, it will still show you negative value. But if you do percentage %u, what that will do is, so actually I will just show you what that will look like. And we will have int average 1 equals, let's just say, -10. And we have average 2 equals -8. And average 3 equals, and we will just have, let's just say 46. And average 4 equals 47. And we have average 1, 2, 3, and 4, and these are all ints. So we can see that we have -10, -8, 46, and 47. Now, when we had unsigned data types, what would happen is that we won't see -10 and -8. Those would, when we had, let's just say, unsigned char, So if we had unsigned char, this would become 246 and this would become 248. And if we do short, and you will see that it will become 655.26 and 655.28. So what's happening is it's coming from the maximum value and then it's coming down. So what should technically happen is that we should see a really big number when we do unsigned int. In other words, the number that we see, whatever number that we see here, the number should not be a negative number. The number should only be a positive number. But when we run this, and we can see that we still see -10 and -8. And 46 and 47 are fine because those are already positive numbers. So what we do in this case is instead of using the %d symbol, we use the U symbol. And what this will do is this will turn it into unsigned. It will give us the unsigned results. And we can see that we have a really big value for unsigned int, and that's because unsigned int has a really long unsigned int has a really big range. I think if you Google man integer or Linux manual integer, it will show you exactly what the range of an integer is, and then you can take the whatever the smallest number is, or you can just pretty much take the maximum number, multiply that by 2, and then add 1, and that will give you the maximum value. Or if you were to find out, let's just say that we have actually, yeah, what we can do is we can actually just find out the maximum right here. So we will do unsigned int and max int u, and I will just enter -1. And we will do %u, and then we will do max int u. So we see 429495, and I think this should be the maximum value that we would have, because if we do 9672, so if we do 296, I think what that will do is it will print 0. So what we will do is now so we have this, and int u1, int u2, and we will change this to 296, and this should be fine because this is the actual max value, and what this will do is this will print a 0. And this should be okay. And this should print 1. and these should be okay. It's just telling us that we need to use a bigger data type because we just cannot contain these in an int data type. And you can see that when we have -1, that becomes 429496 7295, and then this is okay. We have 295, and for 296 we have 0, and for 297 we have 1. So whenever we're working with unsigned integers, what we would have to do is we would have to use the %u symbol instead of using the %d symbol if you actually want to see only the positive values. And I'm actually not sure if I mentioned this earlier. These unsigned are not the same thing as absolute value, and I think by now you already would have figured this out. So what an absolute value is, so what an absolute value is that, let's just say whenever we have -10, that will just become a +10. And when we have -8, that becomes a +8. So any negative number just pretty much gets multiplied by -1, and we just have that number. Yeah, so like I said, -10 becomes 10, -8 becomes 8, -1000 becomes +1000. So I just want to say that the unsigned is not the same as the absolute value. And earlier I had some examples, and I wanted to clarify at that point, but I think now we've gone through a lot of different examples that I think it's just pretty much clear on its own that that unsigned are not the same thing as absolute values. But I thought that maybe I should still point it out. One last thing that I will mention for unsigned is floats and doubles. So when we have floats and doubles, so let's just say we have a double data type, and we will have the variable called GPA, and we can have 3.45. Let's just say we have 3.45, and when we do printf and %f and new line, and we have GPA, and I will have the float data type as well, and we can do GP_f and GP_d, and here we can do 3.95. Oh, so I had an extra D there in the main. So now when we run this, so we can see that we have actually this should go, yeah, so when we run this now, we can see that we have 3.95 for GPF, which is a float data type, and then for GPD, which is the double data type, we have 3.45, and we have these extra zeros, and that's fine. But if you wanted to convert these, and if you wanted to have, let's just say, unsigned float and unsigned double, well, we just can't have unsigned float and unsigned double, and I will show you. So we will have unsigned float, and we will do GPA underscore FU, F underscore U, and we can do 3.95, and we can do the same thing, unsigned double, and we can do GP underscore D underscore U, and we can do 3.45. Yeah, so now what we will do is we will run this and we will see error messages. And that's because we cannot have unsigned floats and unsigned doubles. But everything else should be, a lot of the other data types should be fine, as long as we're working with ints, chars, shorts, and a lot of the other ones that don't, anything that is not decimal, it should be okay. We should be able to have unsigned for those data types. So yeah, I would say that pretty much any of the data types that are not decimal, you should be able to use those as also unsigned data types. But as long as we're working with data types that have decimal or fraction in them, we cannot have unsigned in them. The last things that I will talk about to wrap up this video is const. So what is a const data type? So you can think of const data type as value never changes. So whenever we have any of the variables, so let's just say we have a variable and we have the variable called grade, and let's just say we have a, and we print the value of this. And we can see that we have a. Now let's just say that for whatever reason we wanted to change the value. Actually, no, what I will do is I will also put some other data types too. Int num distance equals, let's just say 15, and short, and we will have length equals 78, so we can see that these print out perfectly fine. Now let's just say that we wanted to change the values, and we wanted to change grade A to grade B, and we want to change distance from 15 to 30. So we will just write distance equals 30, and let's just say that we don't want length to be 78 and we want length to be 100, and we will just do length equals 100. And now when we print these, and grade printf, and we will have the distance, and we will have the length, and we will see first that we have A 1578, and then we will see B 30 and 100. And actually I will put a new line here. And we can see that we have A 1578, A 1578, and B 30 and 100, and B 30 and 100. So this is how the regular data type is. Now what we will do is we will add const before this. So I have not changed anything except adding const here. And what I will do is I will just comment this portion for now. And run this, and we can see that we have 15, 17. And another thing actually what I will do is I will also add GPA, const GPA. S 3.8. Percentage F .5. I just want to run this and show and cover a lot of different types of data types. So I just wanted to add the double data type also to cover with const. So when we run this, we can see that we have A, 15, 78, and 3.8, and that's perfectly fine. Now watch what happens when we try to change the values. Now, if you remember previously, we were able to change the values, but now when we do, we can see that we get these error messages. And the error, what the error says is error assignment of read-only variable grade. And that's because const, whenever we have const, it's a read-only data type. So const, so all of these variables, because we have a const before them, now these are only read-only variables. So we can assign values to them the first time, and that would be okay, just like how we did it right here. But once we have those values, we cannot make those changes. We cannot change the values of these variables afterwards. And this is pretty much, there's a lot more that you can do with const. I think once you start doing more advanced programming, there are things that you don't want to change, and that's when you would there are values that you don't want to change, and there are values that you don't want the user to change. So in those cases, we would use the const data type, so no one can modify those values. That once we get the values, we just want to retain and keep those values. And then we can go ahead and do whatever else that we want to do, maybe make a copy of the value and whatever else that we want to do, and then make the changes on the copy. But that's what the constant data type does, that it's only a read-only variable and we cannot make any changes to it. And that's pretty much it for the const data type. And I'm pretty sure that there would be a lot more different things that you can do. One of the things that I came across recently is having functions that are also const. So no one can make changes to const functions. But for now, I would say that if you're just trying to learn the basics, just try to have different data types, and then try having const, try having unsigned, and that will also get you in the habit of having that muscle memory of typing code, making mistakes, and you will see what works and what doesn't work. And last thing that I will say to wrap up this video, I actually realized that in the last video that I did about data types and variables, I don't think I did as good of a job with variables. So one thing that I want to point out is, whenever we have variables, we want variables to be as descriptive as we can make variables as possible. That's really ideal in programming when we are working with other people and other programmers. So last time I had int num1 and int num2 and int num3. I had these variables, and I would say that these would be, and I think these would be bad ways to name variables, num1, num2, and num3. And that's really because if you're working with a lot of information, the variable should be able to convey what sort of information are you working with. So just like how I have grade here, and then I have distance and length and GPA. So it's really helpful to have variables that convey what the information is. And I wanted to mention this since I think I didn't do as good of a job having descriptive variables in the previous video. So in the future, as you try to work on different projects and as you're learning even the basics of C programming, if you can try to have descriptive variables, that would really help you. And you don't need to have really lengthy and long variable names. You can have short variable names, just like how I have these right here, like grade, distance, length, GPA, and you can think of more. I hope this video was helpful in showing you what a signed versus unsigned data type is, the usage or the syntax of unsigned and the const data type. And in the next video, I will talk about arrays.